This lesson is on solving right triangles. What we're going to do is we're going to find the measure of an acute angle of a right triangle from the measures of any two sides, and then we'll use that information along with what we already know to find all the measures of a right triangle when we're given either two side lengths or one side and one angle. In order to do this, we're going to have to use the inverse trig ratios. Let angle A be an acute angle of a right triangle. Then the inverse sign is that if sine of A is equal to y, then the sine inverse of y will tell us the measure of angle A. Now you'll see what I mean by this as we go along. Basically it is, if I know side BC and I know side AB, I can find the measure of angle A by doing the sine inverse of BC divided by AB. We can also use an inverse cosine function, and we can also use an inverse tangent function. It simply depends on which two sides of the triangle that we know the measurement of, which will allow us to find the measure of the acute angle. Let's look at some examples. Use a calculator to approximate the measure of angle A to the nearest tenth of a degree. Well, notice what I have is I have from angle A, I know the opposite is 16 and I know the adjacent is 20. Opposite and adjacent are related by the tangent function. So what I'll do is set up tangent of A is equal to 16 over 20. Now you can reduce that down to a decimal if you want to, or we can use it as a fraction. But what I need to do is find the tangent inverse of 0.8, and that will tell me the measure of angle A. If I use my calculator to find the tangent inverse of 0.8, it comes out, according to my calculator, to be approximately 38.65980.825. Now this said round to the nearest tenth, so the measure of angle A is about 38.7 degrees. So let's look at another couple of these. Let angle A and B be acute angles in a right triangle. Use a calculator to approximate the measure of angle A and B. If the sine of A is 0.76, then the sine inverse of 0.76 will give us the measure of angle A, and that's about 49.5 degrees. Cosine, if the measure of angle B can be found by taking the inverse cosine of 0.17, and that turns out to be about 80.2 degrees. So a little guided practice. Here's for you to try, and then you can see if you get it right. Comes out to be about 51.3. Now how did we get this? We're looking for angle C. So opposite is 20, adjacent is 16, opposite over adjacent is the tangent. So tangent inverse of the opposite over the adjacent. And we punch that into the calculator, and about 51.3. Find D to the nearest tenth of a degree if the sine of D is 0.54. So once again, we just have to do the sine inverse of 0.54, and that will give us our measure of angle D. So, solving a right triangle. To solve a right triangle means we need all the sides and all the angles. I can find the measure of angle B because I know that this is a right angle here. I know this is 42 degrees, so by the triangle sum theorem, I simply subtract and find out that the measure of angle B is 48 degrees. So now I know all three angles, I need to know the other sides. What I know from angle A, I know the adjacent, and I'm looking for the hypotenuse, or I'm looking for the opposite. So approximate BC by using tangent, that would be opposite over adjacent. So in this case, tangent of 42 degrees is equal to BC over 70. I would have to multiply both sides by 70, and I would get that BC is approximately 63. So we have seen that this is 48 degrees, and this is approximately 63. Now I can find my other side by using Pythagorean theorem, but that would be using an approximation. So I'll use another trig function. Adjacent over hypotenuse is the cosine, and so I'll do the cosine of 42 is equal to 70 over AB. Now I'm going to have to solve that by multiplying both sides by AB and then dividing 70 by cosine of 42 degrees. It's approximately 94.2. So the angle measures are 42, 48, and 90. The side lengths are 70, 63, and about 94. So we now know all the sides, all the angles. Suppose your school's building a raked stage. The stage will be 30 feet long from front to back with a total rise of 2 feet. What a raked stage is it's a stage where the back side is taller than the front, so the audience members can see people standing in the back a little bit better. A raked angle of elevation of 5 degrees or less is generally preferred for both the safety and the comfort of the actors. Is the raked stage you're building within the range? So I look at what I have. I'm trying to find what the degree angle of elevation is here. I see that I have the opposite side and I have the hypotenuse. So opposite and hypotenuse would be sine. So I'm going to use sine and inverse of sine. So the sine is equal to 2 over 30. So sine inverse of 2 over 30 tells me that it is approximately 3.8 degrees. So yes, it is within the suggested range. A little bit more guided practice. Solve a right triangle that has a 40-degree angle and a 20-inch hypotenuse. So what we need to do is set up my triangle, 40 degrees and a 20-inch hypotenuse. Now we need to think of how we get everything else. We got 40 and 90, so we know this side is 50. So now what we're trying to find is x, which would be the opposite of the 40-degree angle. So opposite over hypotenuse, I would have the sine of 40 is equal to the opposite over the hypotenuse. So 20 times the sine of 40 is equal to x. And that gives us 1. And if I'm looking for y, which is the adjacent, then the adjacent over the hypotenuse is cosine. So the cosine of 40 degrees is equal to y over 20. So multiply by 20 and you'll get the other side. What if in example 4, suppose another rake stage is 20 feet long from front to the back with a total rise of 2. So now this time they're not giving us that hypotenuse. They're giving us this side. 20 feet long, a rake or height of 2. So we're looking for this angle here. So I've got opposite over adjacent. And so what we're talking about is the tangent inverse of the opposite over the adjacent. And that comes out to be approximately 5.7, which is a little bit too high for those actors to be comfortable.